Hey folks, so this is section 10.1. It's an introduction to solving oblique triangles. The word oblique just simply means that these are not right triangles. Back in chapter 8, we talked about right triangles and solving them. This is triangles that do not have a right angle. So the first thing I want to look at is there's several different ways to solve, and you always have to have 3 pieces of data before you're able to solve any kind of triangle. So the first example is when you have 2 angles and a side. That could either be angle side angle ASA or angle angle side. Notice that both of those have 2 angles, and then the side, the S, is either between the 2 A's or not between the 2 A's. An example of what this might look like if I were to draw some random triangle. Not worried about, I know that looks like a right triangle, but it isn't. And I would give you 2 angles and their measures. So maybe I would tell you what the measure of this angle is and what the measure of this angle is. So if this were an ASA, that means that the side I would give you would be between the 2 angles. But if it were an AAS, then it would be either this side or this side, where that third piece of information, the side, is not between the 2 angles that I gave you. Either way, in this case, there's going to be one solution to this triangle. There will only be one way to solve this triangle, and you would need to use the law of sines to solve this set of data. The second option is going to be not 2 angles and a side, but 2 sides and an angle. And notice that that angle is not between the 2 sides. Now in this particular instance, this is called the ambiguous case because there's not just one solution to this set of data. Sometimes there's no solutions. Sometimes there is only one solution, but then sometimes there's 2 separate solutions, 2 separate triangles that you would need to solve on this one. But in any case, if there is one solution or 2 triangles to solve, you would still use the law of sines to solve this. I actually have a chart that you can use for solving the ambiguous case, and this is something that we'll be talking about later. The third possibility for set of data is having, again, 2 sides and an angle, just like option number 2, only this time the angle must be between the 2 sides that you're given. Here again, you only have one possible solution, one possible triangle to solve, but you'll be using the law of cosines to be able to solve that. That'll come up in the next section. This is 10.1. We'll be discussing the law of cosines in section 10.2. And then the fourth option is if I've given you the 3 sides and you have to solve to find the 3 angles. There's only one solution to this set of data, but make sure that the sum of any of those 2 sides is always greater than the third side, or you don't have any triangle at all to solve. And in this case, you're going to be using the law of cosines to solve. So let's take a look at what the law of sines says. So the law of sines, I'm going to give this to you in 2 different ways. One way has all of the sides on top. You'll notice the lowercase letters. And the other way that I write it is going to have the angles on top, the uppercase letters. It just depends on what you don't know. If you don't know sides, you're trying to solve for a side, then you'll want to make sure that the sides are on top. If you don't know an angle, you'll make sure that one of the angles is on top. Just makes life a little easier. It doesn't have to be that way. It just makes your solving a little bit easier if you do it that way. And so the law of sines, we'll look at the first way to write it, is A divided by the sine of angle A is equal to little b divided by the sine of angle B is equal to little c divided by the sine of angle C. Now, if you'll simply take the reciprocal of all 3 of these fractions, you'll get the other way to write it. So the sine of angle A divided by little a is equal to the sine of angle B divided by little b is equal to the sine of angle C divided by little c. Just 2 notes here. One is that I already mentioned always have the unknown on top, but the second thing to mention is that you're only ever going to use 2 fractions at a time. This is so that you'll have just a normal proportion that you can solve. Of course, you know that with proportions we use cross multiplying. And so you only ever use two fractions at a time. Now, one other thing to note, and this part is really, really, really important. In fact, it has 3 stars on it. The law of sines will not be able to find an obtuse angle. So let's stop right there. If one of your angles might be obtuse and you have to solve for it, the law of sines will not find that for you. That's because of the restrictions on sine inverse. And so you would have to use another method like adding and subtracting. I'll point that out to you as we go along in working through the law of sines.